Good afternoon, everyone. First of all, please allow me to flip my laptop so that I can run that. Okay, so my name is Khương Nguyễn, and I'm currently both the lecturer in Electronics and Computer System Engineering at the Royal Melbourne Institute of Technology in RMIT University, Vietnam, and I'm also a PhD student in the School of Electrical Engineering and Computer Science in BSc Technical University of Australia in Chesterfield. And today I will present for you the stack algorithm implementation in robot-based mixed-case palletizing system. And this one I work with my team at RMIT University, Vietnam. So this is a little bit information about me. So I'm both the lecturer and the PhD candidate. And for my agenda, I will show you the project overview, right? Solution design, performance evaluation, and the future works. So about the project overview, so the motivation why we reached to this project is about because first of all, the e-commerce industry keeps growing nowadays. The next one will be the changes that were made to match when the material supply with demands over the e-commerce. The automatic warehouse distribution, right, was introduced, and also APS, which is automatic production system, were faster, safer compared to the manual systems. And this is the figure showing us about the growth of e-commerce sale here, right? And that's why we need to do some robotic palletizing. And the project background is, first of all, we do the mixed case palletizing, which one, for example, the pallet, right? We put the one type of box on it, but in this case, mixed case, we put different kinds of box onto that pallet. This is to sort the different types of objects in a single pallet. The next one, the goal is to achieve the most dense, right, and supported arrangement of those pallets. And last but not least, there are surely in this world there are surely some previous research and teams that work, but normally they do manually. And right now, even you know that in the port, right, to put the containers onto the ship or onto the pallet, sometimes they still do it manually. So that's why we have to make the process faster by doing something we call robotics. So the problem statement is that the project goal, right, we would like to work in the sponsorship of ABB, the very famous company, right? We use the robot arms RB660 from them, right? And we developed a fully automated mixed case palletizing system with them. And for the method, we will consist of two components. First of all is the stacking algorithm, and the second one we do some UI UX design for that one. And then the value of outcome is that we expect to have 80% of consistent placing, because right now it is lower than that one, so we aim at that number. And 84% average packing density. Normally with those mixed case is less than that number. 99% of fully supported pallets achieved in safe working environment. So for the literature review, we've gone up with around six main papers on those one. And those papers, right, discuss the use of 2D vision to do the mixed case palletizing. The second thing is that the 3D packaging algorithm are presented in here, and they have some feedback GUI, graphic user interface developed. 90% of packing density was achieved compared to the 70% when done manually. This one is just a market research, right, on why we need to do this project. So I skip it. There's also the market timeline for the palletizing. As you can see, there's many companies, but the IBB, who's the sponsor of this project, is in here, right? And they provide a robot to pick and to do palletizing already, but the one that they are having is not optimal yet. So for the solution design, so first of all, we have the system architecture, and this system, to be easy in understanding, we have just two parts, software and hardware. In hardware, we have the conveyor system, right, for the pallet to run on that. And we have the gripper to pick the pallets on the conveyor. We have the robot controller through PLC to control those gripper and conveyor system also. We have palletizing system. This one, we code for this one, we do something with this in order to make the control to those things here. And in order to talk to each other, we use internet TCP/IP. We also do some manual input, for example, input the codes onto that. Now this one of the two goals we have, stacking algorithms. So you can see the key requirement of this stacking algorithm is to fully automated solution for stacking process. We try to make an optimized algorithm. So far, I think it's optimized, but maybe in the future, and those future works, maybe another teams or from maybe our teams, when we improve our work, it's more optimized. I'm kind of sure. But technical view, right? We do some overview. We deal with the framework of .NET framework. We deal with C# and Visual Studio for coding, and we use all the tools from ABB provided. And now for stacking algorithm, it is to pick the pallet onto this. Pick the boxes onto this pallet. And you can see that in here there are many different types of boxes, right? So how we did it manually. So when people did it manually, they just locate each of the box and trying to see if that box is fixed onto the pallet or not. And based on that idea first, we try to create our work. So from this one, we will have a look at this. Each box will have the height, the width, this one, height, maybe height, width, and depth, for example. We have three factors. From that one, we will, first of all, we forget this depth first. We just look at Y and height. Remember, one literature review, we did with one paper, we have this one, 2 dimension. Okay, let's have a look. For example, we look at it from the top, like this one. Inside, we will have WH, for example. And we will try, right, as they did it manually, right? You put it like this, and you will try to put those boxes like this one. However, there's the research saying that in here, for example, in here 160,000 industrial data, different company, showing us the height of 50 boxes randomly chosen, right? Just have the increasing order between 100 to 300 millimeter, which is not the big one. So based on that one, we think about grouping them together. And when we do the grouping together, we will minimize this number, this set. And by grouping them together, for example, if I accidentally have this box, and by some way I figure out there are 2 other boxes which is having the height of H. For example, I have this one is big H, this one H, this one H1, this one H2. If I have H1 is equal to H2 equal to H over 2, for example, or H is equal to H1 plus H2, I can group them all together. And when I do the grouping together, I can have the combination. For example, I have 1 big box upper and 2 smaller boxes underneath of it. So we make this one, the terminology we call super box. So we group them together in order to minimize those things. That's the first thing. The second one, as I mentioned, we follow the one that people did with the 2D, 2 dimension. So in this case, we would like to solve it layers to layers, right? If I have this bunch of boxes like this, I separate them, for example, in 3 layers. Each layers, I will just solve the problem of 2 dimension, right? And with this one, I just focus on those super boxes, right? And which those super boxes, I just care about the width of them and also the height of them only. I didn't care about the depth yet, right? Because for each layer, the main thing is to satisfy the width and the height of this palette, right? This palette, height and width, right? So that's why we did it by, first of all, grouping the boxes together, and secondly, it is to make them in layers to layers. So in here, this is an example, as I just mentioned, right? This one is more clear for you. It's better than what I draw, right? Sorry. This touch screen having some problem. So in here, we have them grouping together, and you can see this is what I mentioned, superbox, right? And with this one, I try to make one layer first before making more things. In each one layers, I try to place the superbox in such the layer I mentioned, right? After I finish one layer, I will work on to the next layer. And now, we already solved a problem about the width and height already. Now, we work on to the depth. How can we figure out the depth? Here, right? Because each layer, if there's some box taller and some box is lower, then it cannot make a layer that can be balanced, right? So therefore, in this case, if we already finish one superbox, I place this superbox here, for example, and now I will take this height as the reference one. From now on, this is D0, then D0 should be D0, sorry. D0, this is the depth. And for this depth, I will base on this one to pick another box here and make another combination. If this is not satisfying, okay, we put it away and wait until we can make another combination in order to have the optimized layer, like this one. Okay, so this is how we can solve that one. Sorry, because this one we got the sponsorship from ABB, so I cannot show out all the what we call flow charts with more detail, but I try to work it out in the most understandable ways for you all to know how did we work with this one. And after doing the stacking algorithm, we go to UI UX, right? Because it will make something just in algorithm and then it cannot be applied or it is not user experience friendly, then it won't work, right? And so this one is RM. We create the UI UX in here. This is our user flow diagram. Okay, so we start by doing the network scan controller, then we start doing some setup detail, and we verify the robot speed, right? And after that, we choose the type of palette because there will be different type of palette. For example, in Asia palette type, European palette type, and industrial palette type, each will be different, and each will have different kind of use. So we have to choose that one, and then we will add the product detail in here. After doing so, we make the source list, and we can export it in the CSV5 Excel, right? And then we import the customer order. For example, if the customer order have 20 boxes, there will be the chance that maybe 2 or 3 boxes have the same dimension. Especially nowadays when the very high development of the e-commerce happened, surely there will be the same standard of box, such as some mechanical parts, right? So they have the same standard of boxes. So we can group them and do some super box together. So after that, we will choose the suitable stacking algorithm, and then we do some 2D image arrangement, right? And then we can control the robot, right? Telling it to do what to do in the Robot Studio software, right? Let's go to this one. The design infrastructure that we are having for the hardware, we use those two robot arms, but normally we work with this one. We have the robot controller inside of this one, and we have the gripper to test the model. We have workstation and surely the sample palette. The software we work on is this Visual Studio. We work with C#, Robot Studio, and also the ABB robot software. Now I will show you the demo of our work. This one. Okay, so this is the code that we work with C#, right? Now we open the software. Okay, at the beginning, as I mentioned, in this one, in the user experience interface, you will see this one. We will select the controller, whether which it is the IRB 660 or 520, right? In here, and then we select the task for our robot. Then we select the module for that one, and we also put the speed for our gripper, for the robot gripper here. Let's go ahead. Okay, now we do this one first before moving to stack and control and lock, right? So in here, for example, we choose the 660, and then we choose the task, we select the module, and then we put the speed for the robot. Then we just verify, and we come to the next one. In this one, we will have, first of all, we select the type of palette. As I just mentioned, there will be different type of palettes, and then we will add the box. As I mentioned, maybe you already have the box data and it's saved onto the CSV file already. However, we will receive different kinds of orders from customers all around the world. So we need to, for example, there will be new type of box that is not following the standard. We will add new box here. After I add new box here, I click on finish, then it will save onto my CSV file. After that, I will import the CSV file. This is not this CSV file. This CSV file is just for the size of the box. I will import the customer order. How many boxes is this and which type of box is it having into this one. Then after that, I select the algorithm that we created. Maybe this one, right now, I just have one algorithm, but maybe in the future, if I have more than, I can add them here and then click verify. So now let's go ahead and we will see what happens now. Okay, so in here I choose the industrial palette, add new box. For example, we can put box ID, length, width, right, and height and weight for the box, right, and click create, right. After that, right, click finish, and it will be exported onto your CSV file, right. And right now, in order to demo to you, we import from the customer, right. We do the import. In here, there will be 17 boxes, right, from the customer. So 17 different kinds of box. So this is quite challenging, right? And we choose the super box stacking algorithm, right? In here we put the CSV file in here, verify. Okay, so now let's show you this result. Okay, this result, how it is doing palletizing into one palette like this. And in here you can see how many boxes in here. 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. And as remember, we just have 17 boxes from the customer. So it means that 2 layers, maybe 2 layers. 1, 9, another one maybe 8, right? Let's see. So in here, this is level 4 layer. Level 1, level 2, level 3, that's nothing because as I mentioned, we just have 2 layers with this one, right? So those boxes were located into here. Okay, and this one is the file that created by the stacking algorithm. Right? This is what we have. And after that, we go to the control step, control the gripper to put that one. Right? When we click on start, right? Now the robot will pick the first one and place there. Box ID number 1, right? And then box ID number 2, right? It will go ahead. If I fast forward, it will place onto this one. with the appropriate box number, box ID on that one, right? So you can see in here, it shows you that the box placed in layer, so this layer have 9 boxes and we just have 2 over 9. If you fast forward, you will see the box was placed there and how many layers it is having. Okay, so layer 3, we won't have anything, right? So 2, the first box lay in this one is 1 over 8 and this is layer 2 over 2, right? This is how it would work, and we can click on start. After that, this one is the log. When you click on it here, you will see any events that happen to the program that we are running. It will show up here. And for example, if you click back to control and you click on reset, it will be clear for you. And if you click on reset, it will be clear and it will do it again. Okay, so this is just a demo to showing you how our program actually works. Okay. About the performance evaluation and our future works on this. Performance evaluation, first of all, for stacking algorithm, this one, we have 3 decided criteria. First of all, this is how the algorithm can identify single one, pairs, and trios in order to make the superbox, right? Because sometimes it cannot, right? So that's why we need to use this criteria to try on that. The second one will be the effective of making layers, right? By seeing the reference depth D, right? Choosing D0 in order to put the layers. And the last but not least is to build the palette, right? Because the palette will contain many layers, right? So that's why we need that one. For example, in the case I mentioned, if we have 17 boxes and it made A plus 1 for layer number 3, this is impossible, right? Impossible for any company to box or to ship those 3 layer palette, right? It should be made by, should be made by 9 plus A or A plus 9. But however, when we do the palletizing at the beginning, at the first layer, when we try to most dense, as I just mentioned, we make the most dense for this one in order to improve the efficiency of the work. For the UI UX, we have also 3 criteria. First of all, the effectiveness of this one, the efficiency of this one, and the satisfaction. Surely this one based on our customer. If they make orders for us, they will see what happened to that one. And for example, sometimes the effectiveness is that we choose the algorithm but not work as we intended to have. So this one, 3 criteria to make that one. And the future works. For our teams, we would like to add more, right? So multiple stacking algorithm is an option for our operator to choose. The second thing is that to include the 3D image. Right now we just work with 2D, right? But what we would like to see is the 3D image as I just used to explain to you, right? And the last one is integrated this one into the warehouse system. Right now, we just work with the robots and the conveyor to work separately, but not for the warehouse yet. However, as you can see, Shopee, Tiki, many company, Amazon, they will maybe very in need of this one. So why not put it into the warehouse, right? So I would like to acknowledge first of all for the ABB Robotics by sponsoring the robots and research for us, and I also would like to thank our School of Science, Engineering and Technology in RMIT University Vietnam to sponsor me for publishing and coming here. And I also acknowledge my research team. They did very good. I just the last year student, but they can do it very well. And also, I would like to thank my family for the support. Okay, so thank you for listening to me. And if you have any questions, I'm open to discuss. Thank you. Any questions?
So, thank you for the talk. It's a very interesting topic. I can see in your future work this might be extended to supply chain actually, which is great. But what I'm interested in is actually how you create the layout or the algorithm itself. Because from my understanding, and correct me if I'm wrong, this is an optimization problem. And it's in the hardware. So the way I can see it, if you really want this to be an industrial system, it would be knapsack. And knapsack is an NV hard. So you have to select one of the techniques, and this is what I see. You can have multiple algorithms to solve this problem. Did you consider this in your evaluation? And what kind of algorithms or techniques? For example, did you use any approximate or analytical solution?
Yeah, surely. With this optimization,
Yeah, I know that you're
it's
scared
NP hard.
because-
Yeah, it's really
yeah.
in NP hard. That's true.
Yeah.
Thank you for the very good question. Surely, with the right now with the ABB, they cannot, they're not allowed to tell more detail about that one. However, I can say that for the future works, in order to work with this kind, we will need to be some vision camera.
Okay.
So we don't need to input the boxes by really right now we are still import those tiny size of boxes by manually, right? So we will need some vision camera to collect. When we see at those size, it will take that
Feature
one,
extract.
yeah, feature that one, and extract that one, and maybe we will need some QR code in order to scan that box, and we know about its data already. For that one, we will store into the data, we apply some machine learning with deep learning computer vision on that one, and we will see if, for example, if we scan out those things, which algorithm will be suitable to do the palletizing for that case also. So that is our future work on those things.
Thank you. Yeah.
Any other questions, please?
Thank you.
Yeah, so thank you very much.